Good day, guys, and welcome to part 2 in our tutorial series where we are looking at the production of our belt roller support. In our previous tutorial, we would have looked at the production of our main wheel as well as both bushings. In this tutorial, however, we're going to be looking at the production of our base plate as well as our end plates. All right. Again, our base plate, which is the plate on which all of the other pieces will be mounted, and our end plate, the plate through which our axle is going to be placed and mounted onto our base plate. Again, here we have our dimensions given for the pieces, and so again we're going to be looking at the production of both our base plate and our end piece as well. Again, as previously when we looked at our first tutorial, when we were drawing our wheel and bushings, those were drawn from a front view because that's basically the view from which the profiles were seen. If we are to examine the base plate as well as the end plate, the base plate obviously is going to be drawn from a plan view or from a top view because that is the view from which the main features of this plate are visible. Also, if we examine our end plate, we will also notice that our end plate will be produced in basically 1, 2, 3, 4 pieces. And of course, the fourth piece is also going to be produced from a top view. And so for our end plate, it's going to be produced in 4 pieces and then assembled to give that final piece. And so in this tutorial, we're going to be looking at the production of those 2 pieces. I'm going to move over to AutoCAD again, where we're going to be basically continuing on our previous drawing, and I have also gone ahead and have copied the base plate into AutoCAD, and so we're going to go straight into the production of that. Notice too that it also has to be produced from a top view because again that's the view from which the basic features would be seen. I must, however, apologize for the poor graphics because based on the size that I'm going to be sharing the screen at, and that has become necessary based on the fact that I am now sharing um, my screen to accommodate a 3D component as well. All right, and so my drawing area is somewhat reduced. All right, so let's go ahead, sorry, into the production of this. We will observe that from a top view, however, that this shape is derived from a rectangular mass. Yes, and this rectangle has dimensions 116 millimeters in length and 72 millimeters wide. And so let's go into rectangle, select rectangle. Let's give start point anywhere on screen, and let us draw our rectangle using our dimension options in our command line. And our length for our rectangle in this case is going to be 116. Enter. Our width for rectangle is going to be 72. Enter. And let's click to select our rectangle. And so our rectangle has been drawn. Let me also go ahead and locate that rectangle on our 3D side so we can move that closer to where we are going to be needing that. So let's just move that closer. I think I've moved it a little too far up. Let's put it back down a little bit. Say that should be fine. Notice as well that the corners of our plate has been filleted with a radius of 12. So let us go fillet. From your command line, let us choose our radius option, and that's going to have a radius of 12. Enter. And let us also do that in the multiple. With that selected, we go ahead and let us fillet this corner with this one with this one, these two lines, and finally these two. And so I have the basic shape of my base plate. Now, observably, there are 4 holes which has been drilled through. These holes are of, where is that given? These holes are of diameter 10. So we need 4 holes of diameter 10. So let us, from our circle option, we will choose our circle center diameter option here. Our center is going to be the same center as the curve. So let's hover over the curve and the center, our diameter 10, enter. We can now go ahead and copy this circle using the center point as your point for displacement. Hover across other curves and select the centers. Unless you hover over the curve, you sometimes the center for the curves may not be visible. Let us also look again, because we now have that basic shape of our base plate. Now notice at the top there is an or 2 indentations at the side, and on the base there is one in the middle. Those indentations are going to be 46 wide and it's centered. To achieve that, what we do is, let us put a line across our figures at a central point such that we can offset half of that distance. So let us go ahead and offset 23 as in this case, and it's 23 from this line on that side, and it's 23 also on this side. No need for the center line anymore. Let's go ahead and remove that. Alright, and so that is the shape of our base plate. Some extrusions are press pull yet to be done, so we'll get to that in a minute. But before we get to that, notice that the end plate shares the exact dimensions as the piece here that was removed. I guess it was removed so as to accommodate this piece, and so the dimensions of that piece, they're basically the same for both pieces. What that tells me is that I'm going to be needing another copy of this or of that portion when it's time for us to produce our end plate. So let us just secure that piece. Let us trim away the unwanted piece even from now, and delete that piece which is not required. All we're going to be needing for that piece is going to be this piece. So all I have done is just to have that piece taken out before we go ahead and make modifications to this piece. Now the overall thickness of the base plate is given as 13. Notice this portion of it is 10 thick, but then there is a 3 millimeter thickness which is also given here, and so our thickness is going to be a total 10 and another 3 millimeters. From our solid tab, we're going to go ahead and select extrude. I am only going to be selecting the outer line, enter. When prompted to give my extrusion distance, I want it to be extruded in a negative direction, so let's type our negative 13, enter. and so it has extruded downwards. All right. I particularly wanted that because I wanted for my circles to remain on the top, because I'm going to be pressing those circles through. Let me switch to wireframe for a quick minute. And the reason for that is I want to copy these two lines down to the base of our plate. That is intended to give us the indentation on the base of it. So let us go ahead and say copy. Let us copy these two lines, this line and this line, and we want to copy them down the thickness, which was 13 units. Now we have them on the top surface. We also have those lines on the bottom surface, or on the base of the object. Let us switch back to realistic, so the operation can be observed in a more friendly manner. I'm going to be using a command press pull so as to give indentation to these two sides as well as to the underside. So from our solid tab, let us select press pull. You're going to hover into that immediate area that you want to be sunken. For example, this area here, until the area is highlighted. Click, and we're going to be pushing that surface down. It says 3, so in my case I'm going to go -3. Notice that that surface has been pushed 3 millimeters down. But also this surface over here, notice again that surface highlights, needs to be pushed down. So click, push, and type -3, enter. One other thing you might notice though, based on the configuration of your machine, you might notice that when you type that -3, if you get an inverse reaction, in that as opposed to being indented, it elevates. Just undo and type 3 units instead. Alright, so if negative gives you the opposite of what you want, just use a positive value, and that should have that corrected quite easily for us. So we have both sides on the top indented. Let us go ahead and also press up the 3 millimeters on the underside. To do that, I'm going to orbit our object slightly, giving view of the underside of the object. We're going to be hovering on the inner and the central piece. Click, and I want that piece pushed up 3 units. Enter. Notice in my case I'm going up, I type 3, and it still puts it in the opposite direction. I'm going to undo that, and this time I'm going to be using my negative value. So let's go press pull. Let's select the area, press up, and let's say -3. That gets the job done. Let us reorbit so we are able to see the piece in its true form. Notice, however, there are still some holes that are to be punched through. So let us go ahead and give press pull again, select our circle, press this time all the way through, and click. By doing that, we have given the command that we want those holes to be pressed all the way through. Alright, let's also press this one through. That's gone through. Let's go ahead and press the others through in a similar way. Notice though that you have to pass entirely through the object, otherwise you might end up with a hole which does not pass entirely through the object. Let me go ahead and remove these circles, these lines. Once you press pull, the original lines used will be left behind. So I'm going ahead and removing these lines. Can't find this one. All right, let's get off here and select that. I think there are two more under here. I think there would be one here. For some strange reason, it's not selecting. I think there's gonna be one somewhere here as well. And where is that line? I notice I'm selecting and it's hardly even wanting to select. Alright, but now we have achieved our base plate, so that shape is now complete. Alright, so the production of our base plate is now complete. Well, almost. Notice that the edges of our circle is rounded up, but considering that the end plate is going to be sitting on those surfaces, I've been wondering about the necessity of chamfering those edges, and so I'm just going to give them a little fillet. And so I'm gonna go fillet from our solid tab, from our home tab, sorry. Let's go on to your modify. Let's go select fillet. um, let's use fillet, and let us use a fillet radius of 0.5. Enter. We're going to be doing all four holes, so let us also select multiple, and let us change the edges of this object. Alright, let's just change the edges of these objects. Let's also fillet this one, and also they want us to do this one as well. And so the edges are not really that sharp anymore. The edges are sort of rounded up. All right, and that would complete our base plate. All right, and it is onto that that our end plates are going to be mounted. Let us move into the production of the end plates. So let me get rid of my base plate, and also bring my end plate, which I have also already copied. So let me bring that closer to our production area. Give a minute, let me just get it into a reasonable spot where it will be able to view both. As a matter of fact, allow me to just place it back over here so as not to distort the view of everything else. So let's just have it right there for now. Let me instead shift this closer. Alright, let's have it better lined up like that. And so our pieces are coming together quite nicely. Now notice that this end plate now, again, we are going to be drawing just this portion of it from a top view. Notice that from the back end there is a 5 mm setback, which has a step down of 4. Let us go to our drawing here and let us offset this line 5 units back. Let's see, is it 5 or was that one 4? That one is 5. So let's go offset 5, and we are offsetting from this line 5 units in that direction. All right, now so as to extrude, let us solidify the object. So let us go and join, test it. It has been joined. Now on our 3D side, we're going to give extrude, and let us go ahead and check the thickness again of that piece. It says that piece has a total thickness of 4 plus 6, giving us a total thickness of 10. Let us go solid so we can give extrusion of just this piece here, and I'm going down minus 10. again, so as to keep my circles and my surface for pressing on the top. It says that this piece has to be pressed 4 units in. So let us select our press. Let's get in that area until that area highlights. Click and push down, in my case -4, enter. That surface has been pressed 4 units down, or 4 millimeters down. Likewise, the holes are to be pressed through. Do not select on the circle, select inside the circle, press and push through both circles. Alright, again, the base piece for our end plate is now complete. Let me go ahead again and remove these unnecessary lines, like our circle. Take that out. This circle as well. Take that out. Notice again that our the hole in our end plate has a broken edge. They're saying to use a chamfer of 5. Instead, I'm going to be using a radius, a fillet, and we're going to be looking at the reason for that in a bit. But I'm going to be using a fillet, and I'm going to be using radius of 0.5 again. Let's accept that, and we're going to be doing 2, so let's say multiple, so we can break this edge. Likewise, we can break this edge. And that's why I was wondering about the breaking of these edges, considering this entire surface is going to be covered by this plate. But since that's how it is on the drawing, we do likewise. Let me escape that command and continue with the production of our end plate. And so, like I said earlier, our end plate would have been produced in 1, 2, 3, and the circular piece 4 pieces. We have already completed 1 piece. Now, in order for us to complete these 2 pieces, it would be best to have those 2 pieces done together. And so we're going to be looking at a circle, or an inner circle, which is intended to be the hole in the object, which has radius 15. There is another circle, sorry, the hole has diameter 12. Have my apologies. So the bore is of diameter 12, but the entire thing has radius of 15. Now notice as well that the height of that piece from the center to the base is given as 60. What we are actually going to be using has to be that 60 minus the base we had already created. And so what we basically need is a height of 50 from the center down. I'm just making observation because I'm going to be switching views in a minute. And also that there are 2 curves of radius 15 at both ends. I'm going to be switching my view because notice that the production of those 2 pieces, the shape of it is seen more from a left end view. And so we're going to be drawing that from a left end view. So let us switch from our top view and let us switch to our left view. Now here is our drawing being seen from a left view. Alright. Now what it says here is that we basically, and again, let me switch back to our dimensioned piece. It says there is a hole of diameter 12. Let us go ahead and draw our circle of diameter 12. So let's select, let's draw it, say around here, and the diameter is going to be 12. Enter. Sharing that same center is going to be another circle of radius. Center is the same, so let's select that same center. This time radius is going to be 15. Enter. All right, what I have done is to have produced the inner circle of that piece as well as the outer circle. Notice, however, that this piece here is to be attached to that circle. So let us go ahead and also affix that piece. It says from the center we're going down. The drawing says 60, but remembering we're going down minus that 10 thickness, so it's going to be 50 down. Enter. We can go to our right a little bit wider than the circle itself. All right, select the line again, and let's just drag that to the other side. That's going to form the base of that piece. This has a radius of 15. Let us offset those lines 15 millimeters on both sides of our circle, thereby getting the body of that object. The ends are rounded up down here with a radius of 15. Let us go fillet with a radius of 15. Enter. And we're filleting this one with this line. Notice I've lost the rest of the line. Not a problem. Just select the line and drag it back across. In other words, re-extend that line so we can fillet this side here. But when we fillet this side, again we're going to lose this side. So let us go ahead and trim it before we lose it. So let's do a trim, enter, and let us take, as a matter of fact, let's not take it out because we're going to lose it in any case. Let's just go ahead and do our fillet. So let's select fillet with this line and this line. Like I said, we have lost it. Just select this line, take this end and put it onto this end over here. That would complete that piece. All right, now if we notice, let's have another look. We have the basic profile of that piece, but since it has to be done in two separate pieces then joined, let us go ahead and make a copy of the entire thing, such that on one of these copies we will take the circle out and we will trim away this portion, leaving just this piece to form the base part of that object. Now, why was that necessary? It was necessary based on the fact that both of these pieces had different thickness. Notice that this circular portion has thickness of 13, while this flat portion has thickness of 8. And so they had to be done separate. It's best for them to be done separately. We could have done it one piece and use our press pull command, but for this particular drawing I have chosen to do it in separate pieces and model them back together. So let us now join this piece, making it one object. So let's join, enter, let's test it, has been joined. Let's put back the circle on it. So let us copy my circle back on. What we could have done is to keep it as is and press pull, but from previous experience I noticed that I've had some challenges, not certain why I've had those hiccups, and so I tend to prefer to do it as two separate pieces. Let us find those pieces on our 3D side. Let's see where did those pieces end up. Not seeing them. Ah, there it is. Let me move them a little closer to everything else. So let's move them closer towards where everything else is happening. Let's go back and see how close it is now. Still need to go a little closer. Let's move it in a little more. Perhaps here, that's good. All right. Now both pieces now needs to be press pulled or extruded. All right. Both pieces now need to be press pulled or extruded. Let us extrude, or let's try press pull. So let's go solid, and let us press or pull the surface. And this is what I'm talking about. Sometimes that just doesn't work for us. Yeah. So let us then extrude the surface. Let us extrude this piece here that has a thickness of 8. Now that has gone in the wrong direction. Let's go again and extrude using a -8. I should have used -8. -8, enter. Now my extrusion is on the side that I want it to be. I'm going to now use press pull, and I'm going to be pressing my circle, or pulling my circle rather. It's not pulling. Tells me I gotta use press pull again. Extrude again. So let's go extrude. This time let us select both circles for extrusion, and let us extrude our total measurement there, which was 13. Enter. Let's go -13 rather. So let's give extrusion of the circles -13, enter, and my extrusions have been done. Notice however that the hole is still blocked. What needs to happen is it needs to be subtracted. The hole from inside here, or that is inside here, now has to be subtracted. You can't delete it, because if you delete it, then it just leaves the thing solid again. Yes. So what we have to do is to go subtract, select the object we wish to keep, which in this case is the outer portion, enter, and let us now select the inner portion, that piece, and let's subtract it. Notice it's now gone. So that's the piece that is going to be sitting on our end plate base here. Alright, through which the axle is going to be running and all of that thing is going to be happening. For clarity's sake though, let us remove the line, having that done. Let us check our object if there was any, see, notice there is a fillet at the end here. Notice the edge has been broken. Let us do likewise. So let's go back to CAD. Let us have a look-see at that edge in question, referring to this surface around this edge around here, and let us go fillet using a radius of 0.3. Enter, and we are talking about this edge here. Enter, enter. So the edge is nicely broken. All right. Let's see if that's what, if that was the measurement given. None was given, but I'll assume that that's fine. Now, the only thing that is now left on our end plate is our wedge, or our brace. Now notice, the brace has a height of 40 as given here. It's a triangular brace. It has a height of 40, and let's work out our width for our triangle here. The total measurement of this piece was 46 from 116. That left us with 70. 70 divided by 2 gave us 35, telling us that the width of this piece was 35. That was 35. They took 5 off more, left with 30. They took 8 out, leaving us with 22. So what we need here is a brace which is 22 at the triangular base and 40 as the height, has a thickness of 10. Let's go and produce that brace. Again, that brace is not seen from the end view or the profile. Let's switch back to front view. It is from this view that the profile of the brace would have been seen. Let us draw a triangle using line. Now the triangle is 40 millimeters by 22 millimeters, and that takes me back to my point right there. All right, let's select our triangle and join. Wonder, where's my triangle on my 3D side? Let's go find it. There it is. Let's move it closer to our operation. Now that has an extrusion of 10 millimeters. So let's go solid, extrude this object, and we want an extrusion of 10, enter. Now we have our brace. Let us combine the pieces, which is best done from perhaps a wireframe, so we can see our lines lining up. All right, let us move, select your move. Let us move the wedge, holding it at the center at the back and placing that point at the center of this edge here. Those two pieces have come together nicely. Notice I have chosen to do my joining on the 3D side for accuracy's sake. Alright, so it's best to join on your 3D side. Let us now move this entire setup and place on our base piece here. So again, move, select all pieces, enter. Let us select our center point here, because that center point must be placed at the center of this face. Now the piece has come together. Let us do what we call a union of all the pieces. From your solid tab, select union and select all the pieces so that they can be unioned as one. Alright, it's now one piece. As opposed to being 4 pieces as they were produced in, it is now one solid mass. Notice again, finally, that on this end plate, let's have a look. Notice that the corners have been filleted, and they said it has been filleted with an edge bend of 3 millimeters. Let us go and fillet our corners. From our 3D side, let us put back our drawing in a realistic, making it easier for us to observe that the corners have actually been welded. So again, from your modify tab, let us go fillet, giving a radius of 3, enter. Since we're going to be doing many corners, let's do multiple, and let's go fillet our corners. This vertical edge here is to be filleted, so go move in and select that line in the corner, press enter twice. Notice that that corner has been filleted nicely. Select also this corner, enter twice, fillet it again. This corner here and this corner in it, and the corner has been nicely welded. Let's orbit so we can weld on other side. Let us weld this edge here as well. This one here, this one here, and move in and fix one of these. Now our piece is complete. So now we have our end plates. Well, we have one, but could easily be two. So we have our end plate, we have our base plate, we have our bushings, and we also have our main wheel. Since there are going to be two base plates, let us just go ahead now and move our base plate onto the correct axis. Let us move our base plate onto the axis. So let us select move, not our base plate, rather our end plate. Select our end plate. Now when selecting your displacement point, try to select a center point. Any center point would be good, so that we can now place that center on our central axis. Now our end plate is now also centered on our axis. Alright, there's going to be another end plate on the other side. To do that, a simple mirror command would suffice. So let us go and select our mirror option from our modify tab. Let's go mirror. We would like to mirror this entire end plate. So select your end plate, enter. What you want to do is to try to find the midpoint of your axis. I think I just passed it somewhere here. There it is. And that could either be going down or up, doesn't really matter. Just ensure that your ortho is on for perfect 90-degree rotation and give enter. Now we have both end plates. We have our base plate, we have our wheel, we have our bushings, and all of that. Again, quite quickly, allow me to just assemble the pieces, even though notwithstanding the fact that the axle is not present, the hold down bolts are not present, those are the pieces missing. But to show you again how the piece comes together, this bushing again is going to be moved from that point, and it's going to be lined up with the outer face here. You have to watch your crosshair properly lest you miss the spot. The other bushing, let's select that, let's hold it at this outer one and slide that into the wheel at that point. The bushings have been installed. Now let's put our end plate. Again, the end plate is going to be moved, and this central point is going to be lined up with this central point. Likewise on the other side, this end plate is going to be moved onto this bushing at that point. And so the figure is coming together nicely. If we were to orbit, to see the piece coming together nicely, the axle is going to go in that hole when produced. And the base plate is going to be moved onto the object. So let me also now go ahead and move my base plate. Let's escape that, and let's go and move my base plate. I think it's best if we set to wireframe to move the base plate, since that's basically off axis. I'm going to be moving my base plate using a center point, or I could now be using perhaps this point, because that point must line up nicely with this point. And so the object has now come together. Let me put our end plates in another color, making it a little bit more friendly to the eye. So let's go properties. Let's change that from a yellow to perhaps a green, maybe, in terms of a contrast. Let's close that and give match properties. So let's match this two together. Alright, and again, let's take one final look in a realistic view. Again, the colors are off. We're going to be applying material and colors, the appropriate colors, in another tutorial. And so the pieces have now come together. What needs to be done is now the, the axle still needs to be produced, and there are still 4 pins or 4 bolts to anchor this down, which we're going to be producing in our next tutorial. I like to leave things in an unassembled or exploded view, but for this particular one I'm going to be leaving this object assembled, and I'm going to thank you for following in this tutorial, and I hope you will be able to follow and be able to produce this object ultimately on your own. I will also be sending you guys a copy, a soft or hard copy of this bearing, so you can observe the dimensions for yourself and produce this on your own. Thanks for watching, and stay around for future videos. And in that next and final video, we're going to be looking at the production of the axle and the hold down bolts. Thanks for watching.